Yo, hey everybody, in this video I'm going to show you slicing using NumPy. Let's get into it. We'll need an array to work with. For this demonstration, we'll create a 2D array. Array equals NP, call the array function, then we'll pass in a 2D list. There will be 4 rows and 4 columns. So within this list, we will have 4 nested lists. We'll have the numbers 1 through 16. That should be enough for this demonstration. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14, 15, 16. Just for readability, I'll put each row on a new line. There we go, we have a matrix of data, a 2D array. For array slicing, we'll be using the subscript operator. I'll add this as a comment. We will access our array, use the subscript operator, which is a set of straight brackets. Here we will write a slice expression. There's 3 options. You can list a starting index, an ending index, and a step. Each is separated with a colon, a slice operator. Let's give it a try. Let's say I would like the first row in my 2D array. Here's how I would print that. Within a print statement, I'm going to access our array, use the subscript operator, which is a set of straight brackets. Then we will list where we would like to start. Let's access array at index 0. That's going to return the first row, 1, 2, 3, 4. Array at index 1 would be 5, 6, 7, 8. Remember that with programming, we tend to start collections with an index of 0. So that's why the second row has an index of 1. The second index would be row 3, 9, 10, 11, 12. Index 3 is 13, 14, 15, 16. Then if we access 4, it's out of bounds. You can also use negative indexing. Array at index of -1 would give you the last row, 13, 14, 15, 16. Or -2 would be the second to last row, 9, 10, 11, 12. That is the starting index. At which element would you like to start? You can also select a range. We need both a start and an ending index. Let's select the first 3. We'll start at index 0, colon, that's the slice operator, and end at 3. Now the ending index, it's exclusive. So if we need the first 3, that would be 0, 1, 2, 3. That will give you indices 0 through 2. Because the ending index is exclusive, we have row 0, 1, 2. Or perhaps I would like the first 3 rows after index 0, or row 0, so to say. Well, we'll start at 1 then, continue to 4. We'll skip index 0 and print the next 3 rows. If you would like to select everything up until the end, you can omit the second number, but you still need that colon. This tells Python select everything up until the end. Now we'll introduce a step. Let's select every second row, starting with the first. Row 0 and row 2. 0, colon, 4. This will select rows 0 through 3. Remember, the ending index is exclusive. Give me every second row. We'll add a colon, and then the step. We're counting by 2s. This will give me row 0 and row 2. 1, 2, 3, 4, 9, 10, 11, 12. If we're selecting all rows, you can omit the start and the end, but you still need those 2 colons. And the reason that you need them is because if we omit the colons, NumPy thinks we're selecting the second index. So with those 2 colons, if we omit the start and the end, we're telling NumPy select all rows. You can also set the step to be negative. This will return all the rows reversed. So we have the bottommost row, 13, 14, 15, 16, at the top, and the rows are in reverse order. I'm actually curious, what if you set this to -2? Oh, that's interesting. I didn't know that. Now the rows are in reverse order, and we're selecting every second row. I actually didn't know that. I was just curious. I was wondering what would happen if I put -2 here. Alright, so that is row selection. Now we'll get into column selection. Now we're going to get into column selection. We can select specific columns. This first column has an index of 0, because with programming, collections tend to have an index of 0 to begin with. This next column would have an index of 1. The third column has an index of 2, and the fourth column has an index of 3. When accessing our 2D array, we'll need two indices, for example, 0, 0. The first index is for the row, the second index is for the column. Now, if you would like to select all rows, for the row selection, we're just going to add a colon. Because without it, we're going to have a syntax error. Invalid syntax. For the row selection, we do need something here. We're selecting all rows, then access column 0. That would give me 1, 5, 9, 13. 1, 5, 9, 13. Column 1 would be 2, 6, 10, 14. Column 2 is 3, 7, 11, 15. Column 3 is 4, 8, 12, 16. If I set the index to be -1, that's going to return the last column, 4, 8, 12, 16. Or the second to last column would be -2. 3, 7, 11, 15. 3, 7, 11, 15. Now we'll select a range. I would like the first 3 columns. This would be column 0, column 1, column 2. We need a start and ending index. We'll start at column 0, so this number is going to be 3, because the ending index is exclusive. This will print the first 3 columns. We have 1, 5, 9, 13, 2, 6, 10, 14, 3, 7, 11, 15. That is the first 3 columns. Now we'll skip the first column, but print all the columns that come after. We'll start at column 1, or index of 1, so to say, continue to 4. So we skip the first column, this one, we're skipping it, and print all the columns that come after. If you would like all columns until the end of your data, you can omit the step, but you still need that colon. That works as well. Now we'll select every second column by setting the step. We'll be given column 0 and column 2. We have 1, 5, 9, 13, and 3, 7, 11, 15. Now I would like every second column, but we'll start at column 1. That would be 2. This gives us 2, 6, 10, 14, and 4, 8, 12, 16. Then you can reverse the order of the columns. Set the step to be -1. We have 4, 8, 12, 16, 3, 7, 11, 15, 2, 6, 10, 14, and 1, 5, 9, 13. If our step was -2, this would be in reverse order, but we're given every second column. 4, 8, 12, 16, 2, 6, 10, 14. Now we're going to combine both row and column selection. We'll need 2 indices. Let's say that we would like the first 2 rows, but only the first 2 columns. We'll start with our row selection. We're starting at row 0 and end at row 2. 0, 2. Then for the column, we need the first 2. 0, 1, stop at 2. 0, 2. That's going to give me the first 2 columns of the first 2 rows. It's kind of like we're selecting a quadrant. This is a 4x4 matrix, and I would like to select these 4 numbers. Now we'll select this quadrant, 3, 4, 7, 8. Take a guess as to what you would have to write. We're selecting the first 2 rows. We can keep the selection the same for the rows, but for the columns, we're starting at, let's see, 0, 1, 2. 2, 4. But since we're selecting all columns till the end, we can omit the second number, but we still need the colon. So we get 3, 4, 7, 8. Now we'll select the last 2 rows, but the first two columns. What row are we going to start with? 0, 1, 2. Continue to 4, but since we're continuing to the end, we can omit the ending index. Now I would like the first two columns. That would be 0, 2. And that's going to give you this quadrant, 9, 10, 13, 14. Now we need the last two rows and the last two columns. We'll keep our row selection the same. Start at column, let's see, 0, 1, 2. Continue to 4. But since we're continuing to the end, we can omit the second number. And we should get 11, 12, 15, 16. This quadrant. Alright everybody, that is slicing in NumPy. I can't think of any homework for you to do, so to increase engagement for this video, why don't you post your favorite movie in the comment section down below. And well everybody, that is slicing using NumPy.